Hi, I'm Andrew Van Hise of Group A in ECE 493. This week I'm here to talk about the mock lab financial scenario that was made up and the safety considerations for the machine that we didn't actually build but would have built had it been ECE 495. So first off, to talk about the financial scenario, I guess it's more of a side nitpicking thing, but it seems kind of odd to have a president and an assistant or admin assistant for a company with only 4 engineers. And I don't get why the president gets an office bigger than what 2 engineers have to share. But anyway, off to some real things. The way of billing the client kind of took me by surprise, just entirely on engineer hours. Since this is different from what I did when I was at a co-op, it was more along the lines of the hours they were billed for up front, so if engineers took less or more, then the price didn't change. In this scenario, I guess it guarantees a certain amount of profit, and I don't know, just a little bit different. It seems like it could potentially screw over the customer. Aside from that, there wasn't much else on the financial thing, since it wasn't all that real. But more importantly, we've got the safety considerations. I might as well start off with the biggest, and the most dangerous, most likely to happen, though still minor, is since we're dealing with a pressurized air system. Of course, the most likely thing or the most dangerous thing to happen, one would consider, is too much air pressure in the tank between the main compartment and the piston. That would, of course, potentially cause an explosion, and could potentially be quite dangerous to anyone nearby. Overall, though, it's very unlikely to happen, especially with fail-safes in the programming, to make sure that if the pressure got above a certain point with the feedback, it would shut off the more air being let into it. Related things are the tubes, or the tubes linking the tanks, or the tanks themselves just leaking air. Not really a danger to anyone, just more of a, though more likely to happen, not a danger at all. Also, the hydraulic part with the piston could be damaged by the quick change of air pressure in between the things. Could potentially cause pieces to go off and be damaging to others, but still on the lower end of possible injury. Next is the moving piston itself being the main moving part. If one were to put their hand in there or other body part, that could be another source of injury. Electrocution from exposed wires, of course that's probably true in everyone's machine, but it's still always something to consider. Motors could be burnt out, let's say by short circuits or other means. No danger to people, but potentially likely if there was a possibility of poor wiring of some kind. Makes it more of a joke, but someone could be hit by a ping pong ball. Probably absolute lowest point of possible injury, but still there. The machines are actually pretty high up. The R1 we would have built, and especially looking at the others in the lab, potentially you could see one falling over and injuring a person, especially when they were made of metal high up. With the large base, probably unlikely, but possible. Also feel that if the program segfaults, that hurts the programmer's soul. This is very important because it's also very likely to happen given C programming. And lastly, if the power supply could blow, whether this be from a surge from the wall socket or, once again, poor wiring. Probably not likely to cause injury, though likely damage to the rest of the machine. And yeah, so that's about it for all the hazards we have, all of which being physical. We didn't have to worry about any other kinds. Certainly the most dangerous ones being electrocution or explosion from the compressed air. So that's my presentation for you today. Thank you very much.